2-6, as I told you, would be linear programming. It would be some type of story problem where we would not be given the inequalities. We would have to figure them out. So they'll be in there, but not written as inequalities. They'll be written as sentences. And basically, some of these we know that we've done before in the previous section. Did we have to define any variables in the last section? Not really. We were given the inequalities, right? Normally x and y is what they use, so we didn't really have to define anything. Did we have to write the constraints as a system of inequalities? Or did they give us the system last section? They pretty much gave it to you, right? Did we have to graph the system and find the coordinates of the vertices of the polygon formed? Yeah, we had to do that one, right? So we know how to do that one. Write an expression to be maximized or minimized. No, we didn't have to do that. We were just given the max-min function, right? Did we have to substitute values into the expression? Yeah, we had to do that. And then did we have to select the greatest and least result? Yep. So again, we've done 3 out of the 6. And quite possibly you've done the 3 out of the 6 that are most time-consuming, but not necessarily the most difficult. Okay. And as we do this one, and we're going to take our time through this one to try and show you how you can find the inequalities. I truly believe that that could very well be the hardest. This one here, number 4, is normally not that hard, and number 1 is normally not that hard. Number 2 is probably the hardest. This is the order in which your book believes you should do the problem. And it would work. I'm going to give you a slightly altered version of which order you might want to do them in, just because of what's easiest to find. Okay? So now you know what we've done, and now let's go see if we can handle this one. So go ahead, take a second and read the problem. There's a lot of information. You might want to, with your pencil perhaps, kind of underline or circle important information. The fact that it's my telephone company probably is not that important. Okay? You can go through and find what is important in this problem. So take a second and please do so. All right, that should have been long enough to at least get some of it. Would anybody like to share at least one thing that they found to be possibly important in this example? Information that will end up being useful or important. Nobody found anything? Amazing, yes.
Deluxe telephone, nets $9.
Okay, and where's that? Deluxe nets $9. Deluxe telephone nets $9 in profit. Okay, that's important. And following that, yep, do it. All right, very good. Anything else that's probably important? Yes. All right, deluxe telephone requires 3 hours of machine A. Yep. Time. And along with that, yes. And 1 hour of machine B time. Yeah, I think we can probably just keep going with that, right? Standard telephone, 2 of machine A and 2 of machine B. Anything else that's important? Or is that it? Anything else we might be able to use? Yes? Yep. Freeze that and that. So our job is to determine the mix of telephones that can be made during the free time that most effectively generates profit for the company within the given restraints. I'd say there's probably one more thing that's important. We've kind of touched on it, but the fact that there are two different kinds of telephones. Okay? So basically, that first sentence, we don't really need that, right? Let's get rid of that one. Again, not important that it's my telephone company. So let's do step 1. So down here is the question, right? Determine the mix of telephones that can be made during the free time. So our variables, or things that can change, are the number of phones, right? So a lot of people like to use letters that make sense in the problem. Okay? And so let's say D will be one of our variables. And then what would that stand for? D equals, deluxe, be careful, the number of deluxe phones. And who knows, High Quiz Bowl or something, this might be important. That's called the orthoscope. For those of you that really want to know what that is. Never know, that might come in handy sometime. S. Ortho, the prefix normally means perpendicular, so it kind of makes sense then. Yeah. S is number of standard phones. So I agree with the book that it's probably a good idea to figure out what your variables are going to be before you start. Probably a good idea. And the best place to look for that is at the question, which is normally at the end. What do we want to figure out? We want to figure out what mix of telephones is going to make this work. I strongly recommend that you come back to step 2. Okay? But step 2 is to write the inequalities, correct? So I would say come back to that, but then the problem is step 3 is to graph the inequalities, so then I can't do that either. But I think what you should do next is actually go and do step 4. Step 4 is the max-min function, correct? What is it that we're trying to maximize or minimize? That normally can also be found in the question. I'm trying to maximize or minimize what in this particular problem? Profit, right here. Okay, and did we underline anything that had to do with profit? Yeah, that's one of the first things that you had me underline, right? Deluxe phone is $9 in profit, standard phone is $6 in profit. So what if I told you it was 2 standard phones? Would you be able to tell me how much profit was made? Yeah, and you would do what? You just would multiply, right? But do we know how many were made? No. How about deluxe? Do we know how many we should make yet? We don't. So I'm going to write that step 4. You write it where it actually says step 4, but I don't want to keep flipping back and forth, so I'm going to write it right here for now, okay? I'm going to take basically deluxe, right? And my knowledge of deluxe right now is that it's letter D, right? I don't know how many there are, but I know once I figure it out, I'm going to replace D with that number, right? And so we're going to say take D times 9. Why times 9? Because that's how much profit I make on that. Okay. And then I'm going to add to that, because I can make more profit than just that, right? I can make profit on standard telephones as well. And how much do I make on each standard? Well, you already told me that's 6, right? So 6 for each standard. And I didn't down here, but I a lot of times put a little line through my S's so it doesn't look like a 5 or something like that. You can do whatever you need to. So that I would say is basically your max-min function. And if you want to, you can put f of d comma s on there, right? Because that's what our max-min functions have been looking like. Because I am going to find some ordered pair to put in there, right? And so you can write it that way if you want. Any ideas why I would go against the book and have you do that first? Because that's step 4. That's way down the line. Why do that now? Just because I feel like it? What's that? Okay, we already have the information for it. That's good, but we already have the information for the inequalities too. It's all in there. But if the inequalities are the hardest thing to write, why don't we get rid of all the information that shouldn't go in the inequalities? Right? So should the $9 profit and $6 profit end up in the inequalities now? No, because I've already used them. Okay? So now when I go and try and write the inequalities, I don't have to worry about any of that. And I don't have to worry about any of that. Okay? So apparently our inequalities deal with this time. Right? You see how we've kind of eliminated stuff to be used? So always go for that max-min function second. Now let's go back to our inequalities. Whenever I go to my inequalities, the very first thing I look at is, does this say I have to make any of them? Does it say I have to make a deluxe phone? Do I have to make a standard phone? Okay. Then my question is, can you make a negative number of deluxe phones or standard phones? No. So I always look for a minimum or maximum that I can make. Does this give me any minimum or maximum? Does it say I can only make 10 deluxe, or I can only make 100 deluxe, or I have to make 5 deluxe? It doesn't say that, does it? But we do know naturally there's a constraint on that, though. That it has to be 0 or more, right? I can't make a negative number. So two inequalities in this case, seeing there are no, is that D, the number of deluxe, has to be greater than or equal to 0. In other words, that's saying I can't make a negative number of phones. And there was no minimum set in this problem. In other problems, there will be. And how about S? Number of standard. Same thing, right? Now, was that specifically said in the problem, though? Not really. But is that something we should know? That's something we should be able to do. Okay. Now what we have to do is come up with some others, and I have basically 2 more. Is there anything else that's being constrained? Anything else that we can't go above, can't go below, anything like that? Is there anything else in this problem that we're limited? Time, right? So the one limit I have is 12 hours of machine A. I'm not allowed to go over that, right? So I have to stay below that. And the other one is machine B time. And so I look at it this way, is if I can't go over that, then there's time on machine A. So machine A is probably going to have its own inequality. Because I know in machine A, I have to keep it, now I'm leaving space here, I have to keep it less than or equal to 12 if we're talking about time, correct? Because that's what it says for machine A. And machine B also has something I have to stay below or equal to, and that's 8 hours. Right? Now notice again, I left some space there. We have to write stuff in. So let's find something that tells me about machine A time. Well, we already did this, right? We did this machine A time, so let's not look at that anymore. We did that machine B time. Anything else that we underline that talks about machine A time? So a deluxe requires 3 hours of machine A time. So again, I don't know how many deluxe I have, though. But I do know for every single one of them I make, it's going to take 3 hours. So to find out the total number of hours, take 3 times however many deluxe I have, right? And in this case, we know it to be 3D is what I know it as, because I don't know how many I have. Do we know anything else about machine A? Or is that it? I mean, that could be an inequality right there, right? I mean, that could be it. Yes? I know standard? Where? Oh, the next line. That's right. Standard requires 2 hours of machine A. So I know 3 hours have been used up already for each deluxe, but I don't know I'm making any of them. But I know I will add in 2 hours for every standard, correct? Again, if I had 2 and 1, that would fit into the requirements, right? I could put 2 there, and I could put 1 in for S, 2 in for D, and that would fit in. Okay? But that all had to do with machine A. Now, why did I go there? Because I knew I had the 12 hours, and I couldn't go over that. Well, we'll just keep crossing off as we go. Machine B. 1 hour of machine B time was for the deluxe, right? 1 hour of machine B, so 1D plus how many S? Why 2S? Because 2 hours of machine B time. All right, so now we take a look at the problem and see if we are constrained anymore. Is there anything else limiting what we can do? I know that it says machines A and B are used to make both styles of phone. Well, We took that into consideration, right? An employee had an idea that freed up some time. We used that, the 12 and the 8. Well, now we just have to go and determine the mix of phones that can work. And I'm just going to write them over here on the whiteboard so that I can use them on the next page. And we can't forget about the important ones, D greater than or equal to 0 and S greater than or equal to 0. Okay, is everybody ready? Because nothing else constrains us here. All right, now we got to graph these things. All right, so wait a minute. This is an X and a Y axis. We have D's and S's. That's a problem. Only if you let it be. All you have to do now is pick an axis. Which one's going to be D? Dx. Now, what if somebody picked it the other way around? So you're saying make this D and make this S? Is that possible? Sure. What if the other person flips those around? Yeah, their graph will look a little different. Kind of like I think we had somebody the other day that had one kind of flipped, right? And it'll be fine in the end because they're going to use the same, they're going to change up their ordered pairs a little bit in the max-min function as well. And so in the end, we're going to get the same answer. So now D greater than or equal to 0. Now here's where people get confused. A D value of 0, right? So we're graphing D has to be greater than or equal to 0. We'll start with that one. D is kind of like replacing X, right? So X equals 0, what type of line is that? Horizontal or vertical? Vertical, right? And so this is where people get confused and why I wanted you to really know those lines very well. And greater than 0 means it is either the first quadrant or the fourth, correct? I won't shade for our purposes here, but we now know that the second and the third quadrant are no good because that would be a negative number of phones. And then our next one is that S has to be greater than or equal to 0. And really, if you want to translate it, this is kind of like saying this is your X and that's your Y, right? So now it's Y equals 0, and that's this other one. So far, it has to be greater than or equal to 0, and so far we are in the first quadrant. Which makes sense if you think about it. Now we have to go and graph the other two. And we've got 3D plus 2S less than or equal to 12. Once again, I'm kind of taking a hint from these up here as to what I should do. Now it's not an XY table, it's a DS table. Okay. And if I take a hint from up above, we might as well do that again. Because more than likely, one of the two is going to be important. Right? And so we put 0 in for D right there. And S has to be, again, we're trying to make it equal, right? So we're trying that boundary line. And if I make S 0, which is right there, D has to be 4. So 0, 6, and 4, 0. Looks something like that. Was I correct to make it solid? Yep. Okay. I'll give you a second to write that down because I will have to erase that one and put the other equation up. Inequality, I should say, right? Is everybody good with this one? And do you know why I chose the values I did? It's because they were up there earlier. It tends to save time. Not always, but it tends to. And our last one, 1D plus 2S less than or equal to 8, DS table. And again, from up above, these would be likely our best bet. So I put 0 in for D, and S has to be what? 4? Put 0 in for S, and D has to be 8. Like so. Now you notice I waited to shade until the end. Again, that's a strategy I saw some of you using the other day. More than likely, it shades that area that's near the origin, correct? Okay, but we don't know for sure. But if we take a look, we know that it's got to be first quadrant. So either it's going to shade in here, there, or out in there, right? I mean, that's the only places it could possibly go. And so what I would do is test an easy point. in relation to these two lines, why don't we test the origin and see if it works? If it works in both inequalities, then we know we got to shade down from there, right? And so let's again try it in the inequalities. So let's try it in this one first. So 0, 0. 0 plus 0, is that less than or equal to 8? It is. If you try it in the other one, 3d plus 2s is less than or equal to 12, you put 0 and it's 0 plus 0 is less than or equal to 12. And so once again, it works. And so that leads me to believe that that is the location that needs to be shaded, not the other spots. So in this step, we also have to find the vertices. So we'll start with this one, 0, 0. And this one up here, is that one of them I know, or is that one of them we should probably try and figure out? That one that I put a dot on up here. Well, we should know that one, right? But based on how we made our lines, that's 0, 4, right? And this one over here is another one that we should know. Okay. 4, 0. The one that's in question is this one out here. Now our option is to take the two lines that made that and do a system of equations to find out where they hit. Or if we made our graph accurate, that appears to be at 1, 2, 3. And what we would do, I'm not going to quite make it official yet, but 2, 3 should work in both of them, right? And to agree, this is one of the lines that made it. Does 2, 3 work in there? Does it actually make it equal? 2, 3. How about in the other one? 2, 3 and 3d plus 2s equals 12. 2, 3, does it work? Yeah, it does. So 2, 3 actually is the point. Okay. Again, sometimes you'll have to do a system of equations to figure those out, because they don't always end up in really nice places. I think on today's assignment, wasn't there a 7 1/3 or something like that on one of them, or just a strange one? Or 7/4 or something like that. Okay. So now that we have those, again, I'm going to write them on the whiteboard so I don't lose them when I turn my page. Here's your step 4, which was your max-min function, which is, you probably already have it there, right? 9d plus 6s. Now we have to put in all those ordered pairs, which is step 5. So f of 0, 0 equals f of 0, 4 equals f of 4, 0 and f of 2, 3. Well, 0, 0 is probably the easiest because you're going to put 0 in for d and for s, and so the answer is 0. So that means if I make 0 deluxe and 0 standard, my profit would be 0. All right, that makes sense. How about 0 and 4? So I got to put 0 in for d, 4 in for s. I got 24, just doing some quick math. Is there an agreement there or a disagreement? Good. How about 4, 0? 36. And 2, 3. 36. Now, what was the question that needed to be answered? Which one brings the most profit? If I was given this problem and this is the solution I came up with, I would want more information. Okay, possibly taxes, yeah, that could definitely be something I would want to look into. Or, you know, right now companies are looking at, is there a way that I can still do 4, 0 and maybe I could lay people off so I actually make more profit? Okay, unfortunately that's how things are going. And so I would need more information. Or is there supply and demand out there that I should make 2 and 3? Because what does 2, 3 really mean? Make 2 deluxe and 3 standard. This means make 4 deluxe and no standard. It all depends on what people want. So I would want some supply and demand information. Okay? Or shipping costs, exactly. Maybe one costs way more to ship. Okay? Or maybe they figured that into the profit that they had. I don't know. So right now, we would have to say that it's a tie. It'd be 4 deluxe and 0 standard, or 2 deluxe, because I want it in the context of the problem. And 3 standard. Ties. Okay, again, I would want more information. What I'm going to say next is not to scare you. But this one was a pretty straightforward linear programming problem. Because you got to realize, in real business, there are way more constraints than the ones we had here. Okay? But then also realize they have computer programs that do most of that for them. Okay? This is just a general idea so that if you end up doing that, because you got to realize somebody had to write the program. This is how they figure out what should we do. Actually, some companies just guess, but most figure, well, what are we going to do? Okay? And for tomorrow, you have the second example. I have changed from telephones to music. So please finish that one up. Are there any questions? Probably the biggest thing to remember is do step 4 first so you can eliminate information so that it doesn't end up in your inequalities.